Josh, go ahead.
I see no slides yet. I see no slides yet. I guess I'll wait for that. Right? There will be slides.
Sorry.
That looks blue. Yes. All right.
Are you happy?
I am at least a lot happier I was 5 seconds ago. Yes.
Amazing.
Awesome. Berlin is there. All right. Welcome everyone. Thanks for, well, staying in most cases. I hope you're enjoying the 33rd Congress as much as I do. So, me, I'm Jos Portvliet. I live in Berlin, but I'm Dutch. I've been doing open source stuff since the early 2000s, mostly contributing in the KDE community, mostly around marketing and promo. Then I became community manager for OpenSUSE, and a couple of years after that I was hired by my friend Frank Karliczek, the founder of Oncloud, to become community manager at Oncloud, and then later I joined Frank and the other engineers to go to Nextcloud and, you know, continue from there. So today I'm going to talk about, well, I'll quickly introduce Nextcloud so you all know what that is about, and then I'm going to talk about our end-to-end encryption, which is the main subject of this talk. I'll try and detail why we designed it the way we did before I go over the design itself. And in the end, well, I'll go through some edge cases and I'd like to hear some input and feedback and questions. However, if you have questions in between, you can also try to wave at me. I think I can see everyone. And I'll be happy to answer in between as well. So, starting with Nextcloud. Nextcloud was essentially started to help users protect their privacy. So to keep their data to themselves. And, well, to themselves would be self-hosted. So Nextcloud is a private self-hosted cloud. And with the buzzword cloud, I mean file sync and share, but also document editing, audio video calls, communication, collaboration essentially. So the whole thing that you get from Dropbox or Google Drive, Nextcloud is meant to replace it. That's our dream in life essentially. So initially the project was started in 2010, Oncloud, and in 1.5 years ago we split off from Oncloud and continued under the name Nextcloud. So it's fully open source, easy to use. That's I think really important. If you want to replace Google Drive and Dropbox and all these things, you need to be easy to use. Good integration in your infrastructure also for companies. So as an enterprise, if you want to provide file sync and share and collaborative editing to your employees, Nextcloud offers you integration in LDAP and with SAML and, you know, nice developer APIs, mobile interfaces as well, etc. There was a list of features I was just yapping off, sorry. I'm a little confused with the two options here. So let's talk about end-to-end encryption. This has been something we've been talking about for a long time, because if you have a web interface where you can share files and edit files and, you know, send a public link to, you know, your grandma with your holiday pictures, or send, you know, open a video call session with a colleague from work, the web interface is obviously really important in all of that. And end-to-end encryption means that you protect data from the server. That is at least the way we describe or developed end-to-end encryption. So the goal of our end-to-end encryption is to protect your data, even if you can't trust the server for one reason or another. Obviously, Nextcloud is self-hosted, so you should trust the server. In most cases, you can. But for example, if you pick the provider, you might trust the provider, maybe in the city where you live, for example, to keep your data secure. But there is a subset of your data, let's say, I don't know, copies of your passport, your driver's license, and other data, that, you know, you want to really be sure that it stays only yours. Now, of course, then you can just not put it in Nextcloud, but maybe you still want to sync it between your laptop and your desktop and your mobile phone. This is essentially the use case for the end-to-end encryption. So even if, you know, your server gets fully compromised, data that is put in a folder that is end-to-end encrypted should not be accessible by the people who controls the server. Or if you're a company and, you know, you have financial data that you need to release to your investors once a year, You want to make sure that no system admin thinks, gosh, I'm going to earn a little bit extra, by betting on the stock market using this data. Put it in an end-to-end encrypted folder and only the financial team can get at it. That's the use case. And that is what we designed this to protect from. Yeah? And the second element that is really central to the end-to-end encryption is ease of use. It should be simple, because the biggest issue with security is always the user. Right? It's always the user that's the weakest link. So if it is not easy to use, people are going to make mistakes, and if they make mistakes, the security isn't worth much. As an example, if you let users pick their own password for the end-to-end encryption, they will probably pick the same password that they use for Nextcloud in the first place. That password is obviously already on the Nextcloud server, otherwise how can you log in? And there goes your additional security. Or they pick the name of their spouse or something else. So as one example, we designed it so that users don't pick their own password. We give them one. And there are many other areas where you make choices like these. So aside from these, two basic things, protect from the server and be easy to use, the other properties that we wanted in our end-to-end encryption were these. Sharing should be easy but completely secure. It needed to provide confidentiality, integrity, and authenticity. That is authenticity, that if somebody shares a file with you, that you know it's from that person, so somebody else can't impersonate them. Second of all, it needs to protect the integrity. So the server who has access to all the files, even though they're encrypted, should not be able to fiddle with the encrypted files and change them that way. That should just be blocked or not work. Of course, a server could delete some of the files, and in that case the user should be warned. But a server should never be able to modify any of the data that you get. And last but not least, confidentiality. I mean, the obvious thing, the server should never be able to read the data or anyone else in between the recipient and the sender. Now, we wanted to do all this using standard libraries. Rule number one in crypto is don't build your own crypto. So we wanted to use well-tested and audited libraries for all of this. So we've used libraries that needed to be available on the platforms we support. So that's iOS, Android, Windows, Mac, and Linux, as well as PHP, because that's what our server is built in. And we don't really plan on providing a web interface for this because, well, if you don't trust the server, you can't trust code that comes from the server either. So it doesn't make much sense to decrypt on the server, but maybe there will be a use case for that at some point. We don't know yet. We want to keep our options open. And I'm talking about the design here, so it needs to be supported if possible. We wanted to have a recovery option because, well, a base thought behind this is we assume the users make mistakes. The system administrator, on the other hand, in our design, we assume the system administrator knows what he or she is doing. Might not always be the case, but that's at least how we designed it. So it makes sense to have an optional recovery option. Obviously, you should warn users when it's enabled. And if you enable the recovery option, it shouldn't be possible to get access to the data that you uploaded before the recovery was enabled. Otherwise, you just made a backdoor. So that's another thing. We wanted to have it though, because if you have a company and an employee leaves, you still want to be able to get at their data. And that's one of the use cases where you need a recovery option. Well, obviously it needs to be multi-device, so you need to be able to get your files from your desktop to your laptop and to your mobile phone without the server getting access to it. And we wanted to have versioning built in so that if we develop a new version of the protocol, that it doesn't break the old one, so that if we have changes, improvements, we can actually do that. Like new encryption algorithms, things like that. The downside of all of it is we accept some feature loss. So the most obvious thing that you lose is all the stuff that's done by the server. So versioning of files in Nextcloud is done by the server, you lose it. Trash done by the server, you lose it. Online editing of files, well, no surprise, you lose it. Previews in the web interface, again, you lose this. Another thing is, the way we designed it is we want to share on a folder level. So not on an individual file level. You can only share a folder with other people. You can have multiple folders, but you can't share a single file in a folder. You share at the top level. And the last thing that we accepted as a feature loss is sharing to groups. So right now it's not possible to share to groups with this, only to individual users. Obviously multiple, but it's individual. Right. So I'm now going to go into the details of what we have designed. And again, if you have questions or want me to clarify it, because I might go too quick or too slow, please tell me. So I'm going to start with creating an identity, right? So to set it up initially, you create a key or a key pair, a private public key pair, generate it, sign it, encrypt it, etc. So I'm going to start with that. So first part, essentially the initialization. What you do is the client, you turn on end-to-end encryption, and it creates a public-private key pair on the device. Then it requests a certificate from the server for the private and public key, and it uploads the public key to the server. This, if other people share with you, they share to this public key, checking the certificate with it. That's how we kind of protect your identity for other people. Give me a second. So the private key is then stored on the device, on your laptop or mobile phone. Let's say you're using your laptop for this. That is then where this key is stored. Yeah? So next, we want this private key to be on your mobile phone as well. Obviously, we can't just upload it to the server because we don't trust the server. So what we do instead is we encrypt the private key with a 12-word mnemonic, essentially a passphrase. We pick those 12 words randomly out of a dictionary of 5,000 words that are at least 5 characters long. So you get a pretty damn long password that should keep it secure. When it's encrypted with that, we upload it to the server and we show these 12 words to the user. And we tell the user, please write this down somewhere. Now you might remember that I said we assume the user isn't terribly competent, so we also assume that they don't write it down, and we store it in the keychain. So the 12 words are on the device as well in case the user doesn't write it down, which a lot of them won't. Next step. So what we've done now is we have on the server your private key, which is encrypted with a 12-word mnemonic, which you only have on the device and on a piece of paper if you wrote it down. And we have the public key, and both of them are protected with the certificate, as in you can verify the certificate for them. Yeah? So your mobile phone, which you now also initialize, will download the public and private key from the server. It will check the certificates, trust on first use, is what we use here. And then it will ask you for the mnemonic to decrypt the private key. So, well, either you take it from what you wrote down or you look on your laptop and you say, please show me the mnemonic. And then you enter the mnemonic on your mobile phone. It decrypts the private key, stores it in the keychain, also stores the mnemonic in the keychain so that if you lose your laptop and you need to reinitialize it, you can use your mobile phone. And done. We now have our public and private key on both devices and the server never saw anything. So now we're essentially up and running. I'm sorry, I should have switched earlier. So now we're essentially up and running. We can encrypt and decrypt files. So let's talk about how we do that. So we're going to create an end-to-end encrypted folder. We're going to put some files in it. We're going to get them, from another device until, well, that's how you use it, at least between devices. So, step 1. So we create a folder, and you right-click on it, or you use on your mobile phone, you click, and you make it end-to-end encrypted. At this point, your device will create a metadata file. To protect the contents in the metadata file, it creates a metadata file key. Yeah? Now this key is encrypted to all the public keys that need to have access to the folder. Yeah, so later on, if you share the folder, what will happen is that the metadata key will get re-encrypted to all those people so they have access. All the contents of the metadata file are encrypted with this key. we upload the whole stuff to the server. And next step. So now we want to add a file. What we do is we generate a 128-bit key, use it to encrypt the file, and then put the file name and the key in the metadata file. Remember, encrypted by the metadata key. We generate a random identifier for the file, which is now encrypted. We upload the file to the server. We then upload the encrypted metadata to the server, and we're done. Yeah, the server now has an encrypted file with a random file name, and it has a metadata file which is encrypted but contains the name of the file and the key that was used to encrypt the file. So then the next step is your mobile phone will download the folder, download the metadata, use its private key to decrypt the metadata key, use the metadata key to decrypt the data in the metadata file, which will then include the file name and the UUID of the file. It will then download the file, decrypt the file using the file key from the file, and you have your data now on 2 devices without the server having had a chance to see what you were doing. So that's step 2. We now can get files from one device to the next. Next step, sharing with other people and unsharing. This is also the last step. So to share with somebody, you download their public key from the server, you verify their identity using the certificate, and again, trust on first use, you store the certificate and their public key locally on the device. So if it changes, somebody tries to impersonate them, you will refuse that and you will not, share files with somebody who isn't the person that you initially shared with. Then, well, simple, you re-encrypt the file metadata key to the new person you want to share with, to their public key, and then you essentially upload the metadata again, and you tell Nextcloud via the OCS API, I want to share with this person, and then the other person can download the file and use their private key to decrypt it, or the whole folder actually, not just the file. And to unshare, you remove the file metadata key, you create a new one, you encrypt that new file metadata key against the public keys of all the people who need to have access minus the person you want to unshare with, and you upload the new metadata file again. And then you use the OCS API to essentially remove the sharing that you had. This means that that person still has access to the old files, but that's kind of obvious. I mean, if I show you a piece of paper, then I can take the paper away, but I can't tell you to forget what you saw. So it's the same mechanism here. And this is essentially it. This is the way we have designed our end-to-end encryption. The server facilitates, it stores private and public keys, it takes care of the sharing, it helps the devices work with each other, but it never ever gets access to plain text content. So, as I said a few times now, we kind of expect users to be a little incompetent. So of course, at some point, they will, lose the key in the sense that they don't know the mnemonic anymore. Yeah, the 12 words. Now, if you don't know the 12 words, any of your devices can show you the 12 words because they all stored it in the local key store. Yeah, so your laptop, your desktop, your tablet, your mobile phone, they all can show you the 12 words that you need to initialize a new file, download your private key, unencrypt it, and you can share again with other people. But if your safe exploded, your laptop fell in the toilet, your mobile phone fell out of the window, your tablet was ruined by your cousin, and, well, what happens to your desktop? I guess your house burned down. There is a point where you don't have this mnemonic anymore. So don't do that, because we don't have a backup for that. That's just it. otherwise we can't secure your data. However, if your server administrator has enabled the recovery key, you can at least get your data back. You can't get your private key back. Your identity is essentially burned, but you can get your data back. So the way the recovery key works is that when a system administrator enables this on the server, all the users will get a warning that the recovery key has been enabled, so that they know that there's kind of a backdoor now to their data. And a new private public key pair is generated on the server with a certificate, and all users will from then on encrypt their data to the public key of the server, so that the private key of the server can decrypt their data. This private key is stored on the server, but obviously not unencrypted, because otherwise what are you protecting against? So it is encrypted with, guess what, a 12-word mnemonic. This is shown to the system administrator once. He or she needs to write it down and ideally put it in a safe, literally and physically, I mean. And after that is wiped, because it's not stored on the server, because that would be, keeping your keys lying on top of the safe. So what this means is if somebody hacks a Nextcloud server with an enabled recovery key, they still have no access to anybody's data. They would still need the 12-word mnemonic, which should be safely in a safe, managed by the system administrator. But if one of the employees leaves the company, or if one of the users loses all their devices and has their safe burned down, they will be able to go to the system administrator and say, please give me my files back. And the system administrator can enter the 12-word mnemonic, the Nextcloud server can decrypt the data, give this back, and then again wipe the mnemonic from the server memory and storage. So you have kind of an ultimate backup. Now, in our design, we also have a third option, which is to create a new identity for the user using a hardware security module. This part isn't really implemented yet, but we've tried to design it in a way that this is an alternative, and for big companies they would perhaps use that to create new identities for users. But it's, yeah. So, you might wonder, where can I download it? So right now the server side is done, right? It can, it stores the public and private keys. It can facilitate the sharing. It can, deal with encrypted files and recognize them and not try to generate thumbnails out of it and these things. This is done. The Android app can, create a secure identity, send it to the server, sync it from another device, upload and download files. This works. Same with the iOS client. The desktop client right now can create a secure identity, sync it with the server, create a folder, make it end-to-end encrypted, and upload files. It can't download yet. That's the last thing that needs to be finished. As soon as that is done and we've tested it all a bit more, we will release it. When? We'll see. And of course, all the code is online. It's all fully open source. So please go look at it. Also at the design, the way I just described it to you. Go through the code. Check if we made any mistakes, because that's actually bloody important, right? This is why we do it open source. To have smart people look at it. And comment on our, RFC, our whole design, if you see holes. If you have any questions, you can also ask them now, obviously. Cool. Yeah. I guess you should get a microphone, but you can get mine. Here.
Okay, I was wondering that with the recovery key that the administrator has the password from, it's a 12-word phrase. What if the administrator just remembers it when it's in the safe? Then the administrator can use it. Wouldn't it be better to do something that then is very hard to remember for a human, like maybe print out a barcode and on a piece of paper put it in a safe or something like that?
Yeah, so the basic thought behind this was, as I said before, we kind of assume a competent system administrator. And in that, I guess, we kind of assume we trust him or her as well. I mean, I think in a lot of bigger companies especially, you would let the head of IT do this or something like that. And not the whole sysadmin team would not know the 12 words, but just one person. I mean, at some point there has to be a point of trust. So it would be possible. I mean, we could make it a 60 words. I mean, good luck remembering that. I mean, I know there are people, but something like that would be possible, I suppose. Yeah.
Yeah, I was just thinking that actually with the barcode scenario, the whole team could come, print it out, put it in the safe. Everybody has seen that it's in the safe, and everybody knows that nobody knows it's a barcode.
Yeah.
I hope they cannot remember barcode, but they're just looking.
Would absolutely be possible in the design. I mean, it's not married or limited to a 12-word passcode. This is what we picked, but yeah. Actually, I think on the mobile side, I'm not sure we have it yet, but the idea on the mobile side would definitely be that you can, instead of showing the mnemonic, you would show a barcode that you can then scan with your phone to add, so that you don't have to type the 12 words. This is definitely something we thought about. I don't think it's implemented yet, but it's possible. So then it should be possible on the server side too, right? Yeah.
Hello.
Yeah.
Another question. Thanks for the talk. Very inspiring. I use Nextcloud personally. So
Thank you.
this might sound like criticism. So, but you started the talk with don't invent new crypto.
Yes.
But yet the scheme that you describe seems to me very like invented new crypto. Could you?
Well, with crypto,
share
I
some
mean, we don't invent our own crypto algorithms or anything like that. Obviously, the scheme itself, I mean, it's inspired by a bunch of things, including our own server-side encryption, which we developed quite some years ago.
Right.
But yeah, to do this in a secure way, you have to come up with a scheme, right? Because the requirements are always different.
So maybe this will make it easier to answer. Why didn't you use something like OpenPGP or CMS that is a standard for encrypting files, stored files?
It wouldn't satisfy the requirements as I laid them out in my first slides.
Okay, so let's follow up on that. I think it's possible, but another question. What if the 12-word is
mnemonic,
leaked, or if you happen to paste it in some IRC channel or something? What do you do?
Then your private key is compromised. That's like sharing, you know, the password for your PGP key. At that point, you're lost. And so you would need a hardware security module or a new certificate authority kind of solution to be able to generate a new identity. Yeah, I think that would be the only solution for that. So yeah, don't. But of course, you only need it when you add a new device, right? This is very rare. Like you add a new laptop or a new mobile phone, I don't know, once a year, twice a year. So aside from the moment when you set this up on your laptop, your desktop, and your phone, you don't pretty much ever need to think about passwords or write anything down, because it's all done via the public-private keys. There's no need to enter passwords on anything other than adding a device, which is the least common thing that you do, I think, with crypto like this.
So, but I guess, I mean, a common scenario will be that one of your devices is compromised and that key will be leaked.
Yes, that is a risk, and at that point the mnemonic is in the storage of the device. Essentially, this for us is out of scope. I mean, the idea is to not trust the server. If you can't trust your devices either, it's kind of, you know, hard for us. So you should have a locally encrypted storage on your device, and keychains are usually encrypted. So yeah, again, for us it's out of scope, but there are of course ways to protect your devices from harmful effects of being stolen.
Quick question. The passphrase for the recovery, is it once per installation or is it one for every user?
Now it's one per installation, so every user will then encrypt to the public-private key pair, or well, to the public key of the server. So the server has a, you know, has the recovery key. Yeah. No. Yeah, it's essentially, technically, it's not a user, right? The server user. Yeah. Yes, ask.
Hello. I have
Hello.
another question. What happens when you, as a user, when your certificate expires?
Oh, I'm guessing we would give a infinite, like no
Alright.
expiry
Okay.
certificate. Yeah, because the user identities are, as I said, trust on first use, and you can never change them.
All right.
So it's kind of inherent to the concept, and the only way to change them, as I said, is using a hardware security module or a certificate authority. And of course, if you have
Okay.
a certificate authority that you trust, then
Yeah.
obviously you could put a time to life, time to end on certificates if you want.
So if it would expire, would I have to re-encrypt everything?
Well, your public and private key pair were encrypted with it.
So I guess yes.
Yeah, you would get a new identity. No, well, certainly not all your files, because this whole thing is designed that you never need to re-encrypt your files. As you might
But the metadata.
might not, yeah, exactly.
Yeah,
It's just a
okay.
metadata file.
Yes.
So when you share a folder, you don't need to re-encrypt and then re-upload all the files.
Yes.
The only thing you need to re-encrypt and re-upload is the key to the metadata file. Right, so when you share a folder of 600 gigabyte of data, your upload is 5 kilobyte. That's the nice thing about the way it's designed. And if you would have encrypted the files with PGP or something like that, that uses a public key and you want to make it available to other people, what do? You have to re-upload all of them again. And that's of course not nice, to put it mildly.
Okay, so I was late, so sorry if you'd already told this, but I was wondering about the 8 word that the user has to write down. Why you pick it directly from a dictionary and not let the user put it? Because of course, if you take it from a dictionary, the dictionary is the dictionary that someone can use for brute force the account.
Well, we picked a dictionary with 3,000 words. Good luck brute forcing it. I mean, sure. If you let the user pick passwords, though, I mean, we all know what they do, right? Name of dog, name of cat, name of wife, name of husband, name of the kids, and there we have 12 words. That is very easy to brute force. So we explicitly do not let the user pick their own passwords, because users are, again, our model assumes the user is dumb, the system administrator knows what he's doing, but the system is compromised. That is kind of the base 3 tenets of how we designed it. I mean, there's no right or wrong way here, right? It's just what were your assumptions when you designed it, and these are our assumptions.
Maybe I missed it, but how do you verify the integrity of the files in your scheme?
So the files are encrypted with key. I have to look up the exact type of key. I'm not deep into that technical side of things. The 128-bit AES GCM no padding. And obviously, if the file has been changed in any way, well, this won't work. You can't decrypt it. I think I understand it's a property of this algorithm that if you make any changes, then you'll get garbage or a warning, or at least a way to detect that. Again, I would have to check that with a techie how this works exactly. And the other part is, of course, you know who shared it with you. Otherwise, your public you check this on the certificate. So the certificates make sure check the authenticity, and the integrity has to be protected by the algorithm. And some of this is already like a couple of months old, so it might be that we've picked another algorithm that does a better job at this, but there I don't know the details.
I guess that you can disable users. Can you also revoke keys or certificates?
I don't think so. Obviously, as server, you can simply stop handing them out when a client asks for them. That should do the trick, in practice. Because obviously, if you share with somebody, you first have to download their public key from the server to be able to share with them, and if that doesn't exist, then you can't share. On the other hand, once you have shared, the other person will store your information in their keychain, and as long as the server gives them data, they will be able to decrypt it until you re-encrypt the metadata key, of course. But yeah, in practice you would remove the person from the server and then they can't sync with the server, and yeah, it's game over at that point. I mean, we try to rely on the existing sharing and user handling mechanisms in Nextcloud as much as possible, because they work, they scale, they're reliable, they've proven themselves. So, yeah.
How do you deal with changing files? Do you just take it as a new one? Like, if I edit a file in my local
Yeah, so if you
folder?
edit the file is essentially encrypted with a new key. So a new key is generated for the file that is then used to encrypt the file and uploaded again.
But does it use the same metadata?
No, at that point you also need to regenerate the metadata file, put the
So-
new key in there, etc.
And so if I share something, I only share this version.
No, as long as people have access to the metadata, they will simply download new versions of the file, decrypt the metadata, use that to decrypt the file, and they get new versions of the file as well. And there's change detection built into the Nextcloud server, so they will get, if they use a sync client, they will simply get the latest version.
Okay, so you use the same metadata keys?
Until you decide that, one person in the list doesn't have access anymore. At that point, you change the metadata key. So you
Okay.
cycle through metadata keys, but only when it's necessary. If you change the access rights.
All right.
Very good.
Grill him. As long as he's on the stage, grill him.
Oh shit, how much time do I have left?
Just a question about the mnemonic.
Yeah.
You use a 3,000 word dictionary
I believe so, but don't shoot me, I might be wrong.
because
but
it
I think
reminded
so.
me a lot at the Bitcoin or in cryptocurrency used Sheem, which uses, I think, a 4,000 word dictionary. So I was wondering, don't you use the same, and why don't you use the same?
I don't know. I know. I have to look up the detail of exactly what dictionary it is, but it's a pretty standard 3,000 word English dictionary. The design doesn't depend on it in any way. I mean, you could also take a 6,000 words. You can do it in Greek if you want. It's just more people can write 12 English words than 12 Greek words.
Okay, I just want to point out the advantages of this because it's a proven Sheem and it's
Yes.
identically available in different languages, and it also includes, and that's a question, a checksum, like the last half of the last word is a checksum over the whole thing. Do you have these two? Like, can you tell the user if his mnemonic is right
I
or
don't
wrong?
know exactly. I can get you the answer if you like, because I think we picked we didn't make our own dictionary. I know we picked it from somewhere, and I'm going to guess there was some thought put in that, but I don't know the thoughts behind that.
Thanks.
No.
Can I give you the microphone?
Hello, do you have any Nextcloud stickers?
Yes,
Seriously though, I'm not a great coder, and I just wanted to ask what other ways can people get involved or contribute to the project? So if you have any other, or if you could maybe give an idea of the project and how people can contribute.
Well, there are obviously a lot of ways to contribute. Aside from coding and reviewing stuff like this and asking difficult questions about it. Well, there's the usual, I guess, documentation, but also like promo marketing and telling other people about it. That's, I think, every open source project benefits from that. Honestly, I think just helping other users is really important, because there are a lot of people asking questions on our forums, trying to get help. It's on help.nextcloud.com, and if you run a Nextcloud server, you know a little bit the how and what of it. It's really appreciated if you, especially if you use the forum sometimes to get answers to your own questions. Please help answer a couple of questions there if you happen to know them, because that really helps, I think, the community as a whole forward. So I hope that suffices as some inspiration. Anyone else? Questions? I'm excused. No more?
Then I will have the last question, dear Josh.
Go ahead.
What's your password?
Well, it's a 12-word mnemonic and I don't remember.
That's terrible. Don't. Okay, applause to Josh.
Stickers.